So my lab studies phytochemicals, which are small molecules that plants make. Those phytochemicals are important for human health because we consume them daily in fruits, vegetables, or herbal teas. For example, fruits and vegetables produce various phenolic compounds, which are antioxidant and good for human health. Some medicinal plants produce compounds with anti-cancer activities. So my lab studies how plants make those compounds and how the production is controlled. Then later we can use our findings to increase the production of desirable phytochemicals. However, increasing those compounds in plant is not simple. Plants make those compounds often to protect them from stresses such as herbivores or pathogen attack. So if we make a plant produce more of those compounds, plants often become small and do not grow well because plants under attack shut down their growth to use their resources to protect them from stresses. On the other hand, if we make a plant too big, they will be more susceptible to disease than smaller plant. Basically, plant growth and defense abilities are connected. When plant growth increases, defense decreases. When defense increases, plant growth decreases. We call this a dilemma, plant growth defense trade-off. What growers want is to increase both yield and disease tolerance. However, it is very challenging to do that because of this trade-off. My lab recently found a clue to explain the growth defense trade-off. We found that plants make plant growth hormone using precursor of a defense compound. In other words, the production of a defense compound and production of plant growth hormones are connected.
So there exists a trade-off between growth and defense in plants, and in order to better understand the growth pathway, we need to block off the defense pathway. So that's what we're doing in this lab, at least for my project, is trying to develop a mutant to block off the defense pathway so we can better understand the growth pathway.
Currently working on to figure out how this connection occurs. So we hope in the future our research will help to generate stress-tolerant crops without sacrificing their yield.